Hello again everyone, welcome back to ptet.chemistry channel. This is the start of this section B topical MCQ for classification topic 10.7. That is just to do with carboxylic acid and its derivative, I guess, esters, infrared, etc. etc. In this section B type of MCQs, which is quite common in the Cambridge International Paper 1 MCQ, it's basically about this kind of three statements. Where the options A refers to 1, 2, and 3 being relevant to what they're asking, B refers to 1 and 2, relevant to whatever they're asking, C refers to 2 and 3, and for D, only 1 is relevant to whatever they're asking, whether that's correct or incorrect, it all depends on whatever they're asking. If you jump straight into this question, it's saying that you have this flavor of pineapples. So, pineapples, you can get Hawaiian pizza, right, with ham and pineapple. Anyway, so this gives you the flavor of pineapple. And as you can see, you have an ester linkage there. So esters are used as flavorings, okay, because of their sweet smell, because of, I guess, the taste as well, because they are used as flavoring. You also use them as solvent because of their sweet smelling nature as well. When you heat it under reflux with base, so what you're doing is you're doing base hydrolysis of esters, okay, and then you distill them. What compounds will be found in the distillate? This is actually a very confusing question because I can tell you a lot of students, when they think about base hydrolysis, okay, let me tell you a little bit about the story, okay. In the mixture pot, this is before distillation, because you do distillation to separate things out based on their different boiling point, right? That is to do with distillation, and you have done this since GCSE and O level. You distill in order to separate out stuff with different boiling point. So if I just draw out this ester, so CH3, CH2, CH2, CO, like that, CH3 or C double bond or CH2, CH2, CH3. If I hydrolyze that ester, if I do base hydrolysis means I will not get my acid, instead I will get the salt. I get the sodium salt because I use NaOH. I will also get the alcohol because alcohols are not basic, alright? This is what I will get in this pot. However, what I did was I do distillation. So a lot of students, they will have stopped at this stage. Nah, I don't like that. I like think. Okay, a lot of students will have stopped at this stage. In fact, most of the time, the question will just stop at this stage, as in what are the product you will get, which means they will include that. However, the most important thing here is you distill it. You distill it based on different boiling point. This is an giant ionic structure. They do not come off on distillation because they have high boiling point. All right. So what actually comes off in distillation will be the simple molecules, the one that can be boiled off. That would just be the methanol. You do not get the salt of the carboxylate, because that is giant ionic structure, high boiling point. They are not simple molecule, unless if you have the carboxylic acid, then yes, they can come off as the distillate because that will not have giant ionic structure. So a lot of students, I guess, when they see this question, they'll probably be thinking, oh, base hydrolysis, but they didn't take into account that you are doing distillation, different boiling point, high boiling point, giant ionic structure, wouldn't be distilled off easily at all, in fact, okay. Oops, sorry, did I? No, okay. So 2 is incorrect, only 1 is correct. And of course, this is the wrong alcohol that you get when you hydrolyze this ester. So 3 is definitely incorrect. Moving on to the next question. This is again about hydrolysis, partial or total hydrolysis, aqueous sodium hydroxide. In this question, they are not talking about separation by distillation, so we can be thinking about getting the carboxylate salt. This is the base hydrolysis of the ester. Where's our ester? Our ester is here. Okay, so I'm going to have bracket like that. what we have is we have a CH3O. It's easier if you draw out, okay? CHCO, O minus, Na plus, because I'm using sodium hydroxide, and then I get HO, CH2CH, CH2CH3, CH. Okay, this is getting more and more complicated, okay? As in, like, the formula is quite long and tedious, but really nothing has changed apart from the ester. Nothing has changed apart from the ester. All of this doesn't change, okay? And you don't have any other acidic group, only the acidic product gets deprotonated. So when you look at it, that is CH3, the benzene, CH, CHCO2 minus, Na plus. 2 is definitely correct, okay? If you look at number 1, so it seems like they have put this into a branch, okay? They've labeled that. If I were you, I would think about longest chain hydrocarbon. So, sorry, there's 1, 2, 3, 4, 5, and 6. So there's 1, 2, 3, 4, 5, and 6. And then on my side chain, I obviously have 2 carbon. I have 2 carbon on my side chain, bonded to carbon 2, because it's carbon 1C with 2 hydrogen and 1 OH. This is bonded to carbon 2. So indeed 1 is correct. What you do not get is, you do not get this because you do not break, so no reaction with carbon-carbon double bond, because you are not doing any oxidation of the carbon-carbon double bond. You're just doing base hydrolysis of the ester. Only 1 and 2 are correct. That's option B. Next question. This is about monopotassium citrate. So which statement about it is correct? It can act as a dibasic acid. So these things looks confusing because first of all, it talks about acid, but it talks about basic, okay? So the most important thing in this kind of definition is that it's an acid, okay? It's an acid. It's called dibasic acid because in one of it, it has got 2 times carboxylic acid. It can react with 2 times equivalent of base, okay, per acid molecule. So that is exactly what it means by dibasic acid. It's still an acid, but it's because it's got 2 carboxylic acid group in the whole molecule, it can react with 2 times hydroxide. 2 times equivalent base is not that accurate. 2 times hydroxide per acid molecule is more accurate. 2 is correct. It can form optical isomer is incorrect because these 2 groups, CH2CO2H, I hope you can see this is exactly the same as that. That carbon is not chiral. None of the other carbon is chiral. So if 2 is correct, 1 is wrong. You only have one choice, which is C, which means 2 and 3 are correct. And in fact, it can form ester with both acids because this bit can form ester, can esterify with alcohol, and the other bit is the alcohol can esterify, meaning to say it can undergo condensation reaction with the counterpart. In this case, the counterpart is the acid, the counterpart here is alcohol, and you did condensation in GCSE and O level as part of your condensation polymerization. So this is really just a revisit of your O level and GCSE, and that's why you gotta master your basic stuff from GCSE and O level as well, yeah. In this next question, so they're asking you about lactic acid. Actually, lactic acid is very, very popular question in A-level chemistry for obvious reason, because it's got both alcohol and carboxylic acid group. If I draw out the the skeletal formula, CH3CH, because carbon form 4 bond, I only shown 3. There's a H there, OH, CO2H, okay? I can straight away tell you it's got an optical isomer, because the carbon is bonded to a hydrogen, a CH3 or OH and a CO2H. And then they say 2 hydrogen atoms can be involved in hydrogen bonding. That is correct because the first one is this thing, delta plus, delta minus. The second one is the one from the carboxylic acid. So 2 hydrogen atoms per lactic acid molecule one from the OH, one from the CO2H involved in hydrogen bonding. Show the dipoles. Show what else? What else are you going to show? What was the thing I was going to say? Lone pairs. So you got to show the lone pairs on the oxygen. Okay, and then you got to label the hydrogen bond. So these are the key criteria when you want to score the marks in theory papers to represent the hydrogen bonding. All right. Lactic acid would form an aldehyde when you oxidize by that. If you think about it, this is a secondary alcohol because the carbon with the OH is bonded to two other carbon. You can never get an aldehyde from a secondary alcohol. You will get a ketone. Okay, so only 1 and 2 are correct. That's option B. This is the last question of these section beta MCQs for 10.7, carboxylic acid and esters, well, and its derivative, I guess. Which reactions are possible with this structure? So this is down to identifying functional group. You see this carbonyl and you are nice and happy. You might think it's a ketone, but always check whatever is on the side. It's got the alkyl, it's got the oxygen. This is actually ester. Okay, and then this thing is alkene. This thing there is called a benzene ring, and you will do more in A2 chemistry. So the fact that it was back in 2006, many years ago, when AS and A2 were not distinguished like they are now, yeah, okay. So syllabus does get changed, specification changes, so you need to be aware of this kind of thing, okay. So aqueous bromine is decolorized, that is correct, because you can do carbon-carbon double bond, electrophilic addition. You got to master these few key mechanisms and understand them. Okay, you can watch them in my topical playlist on organic chemistry mechanism, or you can go through the hydrocarbon 10.2, which covers everything from alkane and alkenes. All right, the bond. Okay, so this is not to do with chiral carbon. This is to do with the bond. It's hydrolyzed by heating with aqueous sodium hydroxide, and that is correct because that is to do with base hydrolysis of esters. And this bit is the carboxylic acid. Because you're under basic condition, you will get a carboxylate, C double bond O minus Na plus, just like here, base hydrolysis. All right, you don't get the carboxylic acid, you get the carboxylate salt because you are under base hydrolysis. Of course, this one will give you the alcohol, and alcohols are not acidic. Well, normal alcohols are not acidic, so they just give you the normal alcohol. So 1 is correct. And they say an orange PPT is formed with 2,4-DNPH. This one reacts with aldehyde, C double bond O. It reacts with ketone, C double bond O. In a condensation reaction, these are not forming ester or amide, but it's forming something else, but it's also known as condensation reaction. I recommend you go through the AS chemistry concept if you don't know how these two aldehyde and ketones, C double bond O, reacts with 2,4-DNPH in a condensation reaction. Go through that concept, find out what is the balance equation, because when they do come up, they come up and it's part of your AS syllabus. All right, so you don't get an orange PPT there at all because you do not have an aldehyde or ketones in this molecule. It all comes down to identify functional groups correctly, identify the type of reactions associated with a functional group. All right, so 1 and 2 are correct. That's option B. This is the end of these 5 question tutorials of the section B topical MCQs. So if you enjoy these videos, please share them with your friends, your class group chat, your juniors, your seniors, your teachers, whoever else you think might find this channel useful, based on the other topical playlists and the other full paper tutorials. So don't forget to subscribe if you haven't, and I'll see you in the next video. Thank you for watching.